Hello, yeah, this video is an example of data analysis using R for correlation analysis. Okay, so basically I will show you how to compute Pearson's correlation coefficient and Spearman's rule, and also how to do hypothesis tests, and how to calculate 95% confidence interval for these correlation coefficients. And then I will show you how to produce a scatterplot matrix and also how to generate correlation network graphs. Okay, let's read it in the data. So this is an example data with the Framingham 1000. And here I picked the time to MI and total cholesterol level. Let's assign them to X or Y. The basic tool for before we calculate the correlation is the scatter plot. So it looks like that. And then we can calculate correlation coefficient by using the core function X or Y method equal to Pearson. And whoops, it gave us an NA. So why that happens is probably because there are missing data in X or Y. So how to deal with missing data? Let's look for the help file here. You can see the COR and it looks like okay, so there's a use argument here. The use argument is an optional character using a string, giving a method or computing covariances in the presence of missing values. And it has everything, all observations, complete observations, NA or complete, or pairwise complete observations. Okay. So in here, in this core function, the way to deal with missing data is using the use argument. So let's try use equal to complete observations. Oh, we do get a correlation coefficient. And if we use NA dot or dot complete, we get the same. And or if we use equal to pairwise dot complete dot observation, we get the same. Okay, so basically there's no differences when we use any of these three options here. Okay. To perform inferences on the true correlation, test if the true correlation equal to 0 or not, say we can use the core dot test. And this one, it does have the NA dot action, so give us an option how to deal with NA. The missing values, so we can say NA dot action equal to NA dot omit. And we do that, and it gave us the correlation coefficient estimate, the t-value, degree of freedom p-value, and the alternative hypothesis, and also the 95% confidence interval. So this core dot test function actually gave us everything. We don't really need to use the core function to calculate the correlation coefficient, right? Okay, so if we want the Spearman's rule, we just using the same syntax, but we add method equal to quote Spearman. So this will give us the Spearman's rule and the p-value for the hypothesis test, and also it told us the exact p-value cannot be computed because of ties, and it doesn't compute a confidence interval. So, and to compute a confidence interval for Spearman's rule, you need the R package or the conf intr. Okay, I covered that in another video. Okay, the next topic is I want to show you how to generate scatterplot matrix, which is you can look at the correlation or the scatter plot for multiple variables at the same time. So here, let's say we look at the time to MI with the total cholesterol level, age, systolic blood pressure, and the diastolic blood pressure. So let's look at the help file. So this help file tells us the way to use pairs. We need to put, we better put all the data, the columns we want to plot out in the matrix. So here, I want to find out the column number for these variables, time MI, total cholesterol 1, age 1, SYS BP1, DIA BP1. Okay, so I use this syntax, which names of DF, and then in this vectors of variable names. And now you can see the column numbers for these variables are 11, 19, 20, 21, 22. So I just say pairs df, and then I just put in that column number, which is applying the pairs function on just these columns of the data frame df. Okay, now it gives us the pairwise scatter plot between all these variables. So it can be a little bit messy, but it better than you generate scatter plot pairwise, like every pairs of the variables. Okay, you can just exactly look into here. You notice the two blood pressure measures are highly related. They're very close, like on the straight line. Okay. All right. But if you want more detailed scatter plot matrix, I'll show you another way. We can use the ggplot2 and the ggalley package. So let's load that in. And then the syntax is the gg pairs. You get the degree of df, the data frame, and you can specify columns equal to these column numbers, and then get a title, and then say axis labels show. Okay, it's take a little bit longer time, and also R tells you that there are missing values removed during the process. Now you look at this scatter plot matrix, so there are a lot more information. So you can see there's the correlation coefficient, and then there's the stars indicating significance. Looks like they're all significantly related. The correlation between the total cholesterol level and the BM time to MI is a little bit low. The others are relatively high. And I think they're ranging from 0.1 to 0.3, or even you have a 0.78 between the two blood pressure. Okay. All right. And also I noticed something relatively new called the correlation network. And I'll show you what it is and how you can draw a correlation network graph. So you need the library tidyverse and the library CORR. And the syntax is you say df and you specify those columns. So you have to pick those columns from df, and then you use this operator to feed ask R to apply the correlate function in the COR package to these columns, and then feed them into the network plot. And now, remember we, based on the correlation coefficient from the last scatter plot, most of them are about 0.1, so let's specify the minimum correlation as 0.1. Okay. So you can see it's on the right-hand side. It shows you the correlation relationship among these variables. So if two variables are correlated. They are connected by a line with different thickness and different coloring. Now it looks like the more blue is close to more correlated, like close to 1.0, and I think more what's this, like brown, light brown is -1. Okay, and you can see the total cluster level, since its correlation is really small with the time to MI, so that line did not show here. Okay, so this gave us some idea about the correlations among these variables. So blood pressures and age are all related to time to MI, and there's a very strong correlation between the two blood pressure variables. Okay, hope you like this video and learn a little bit about correlation analysis.